Hello everyone and welcome to the chapter number 64 of Blender Master Course, Rigid Body Physics. In this chapter, we'll be understanding about the basics of physics and simulation in Blender, the various different options available in the rigid body physics, and in the end, we'll also be creating this amazing animation with some candies falling in a glass bowl with the help of rigid body physics. And if you are new to this course, then you can watch the previous 64 chapters from the link of the playlist given in the pinned comment. Now the first question which arises is that what exactly is meant by the term simulation in Blender? So simulation refers to an animation where the dynamic events which take place in the real world are simulated in an animated sequence. In simpler words, simulation simply means creating animations in the 3D softwares like Blender where the things interact with each other just like the real world by obeying the laws of physics. To understand all this in a practical way, let's begin this journey of physics and simulation with the concept of rigid body physics. Now to enable the rigid body physics, we need to open the physics properties. So for this, click on this icon with the name physics properties, and over here we have a type of physics known as the rigid body, and if I select it, then now the rigid body physics is applied to the cube object. Now this rigid body physics allows the object on which it is applied to interact with other rigid bodies in the scene, resulting in collisions. Now with all the default options enabled in the rigid body physics, if I press the space bar to play the animation, then you will see that the cube will begin to fall downwards, and this is because being a rigid body, the effect of gravity is acting on it. Now suppose I want that when I play the animation, this cube will move downwards, but in midway through the animation, it should hit a plane object. And for this, we need to add a plane in the scene, and then we'll be applying the rigid body physics to it. In this way, both of the rigid bodies should be able to collide with each other. So to do this, let's first move this cube in the Z-axis and place it over here. Now press Shift plus A, go to Mesh and select the plane, tab into the edit mode, press S to scale it up, and we'll scale it up 5 times. Now in the physics properties, if I turn on the rigid body for this plane object also, then now our expectation is that both of these objects, being rigid bodies, they should be able to collide with each other. However, if I play the animation, then now both of these objects are moving downwards due to the effect of gravity. And to solve this problem, we simply need to change the type of rigid body for this plane object. By default, it is set to active, but if I change it to passive, then in this case, the effect of gravity will no longer work on the plane, and as a result, it won't be able to move downwards. So let's play the animation again, and now you will see that the cube object will collide with the plane, and in this way, they interact with each other. Now if I select the cube object again, then in the rigid body physics, we have some more settings like the dynamic and the animated, and these are the two fundamental settings which simply define the movement of your cube in the scene. If the dynamic option is turned on, it means that the rigid body physics will work on the cube, meaning that on playing the animation, it will fall downwards and interact with other rigid bodies. And if I turn it off and replay the animation, then in this case, the laws of rigid body physics will no longer get applied to the cube in the scene. And now the next thing that we have here is the animated, and if I turn it on, then now it will only consider that particular animation which we create by inserting the keyframes in the timeline editor. For example, if I take the pointer back to the frame number 1 and press I to insert a keyframe for this particular location, rotation and scale, then I'll take the pointer to the frame number 40. Let's also move the cube in the y-axis and place it over here. Now to insert a keyframe at the frame number 40, press I, and if I try to play the animation by pressing the space bar, then you will see that we have a simple animation created with the cube moving in the y-axis. However, if I go to the rigid body settings and turn off the animated, then if I replay the animation, then you will notice that the animation that we manually created is no longer getting applied to the cube object. So as a conclusion, the dynamic option controls whether you will see the rigid body physics applied to the object or not, and the animated option controls whether you will see the manual animation that you create in the scene or not. For now, I will be turning on the dynamic option. Let's also delete these keyframes that we created. So in the timeline editor, press X and select delete keyframes. Now before moving ahead, do ensure that in the object data properties, you change the value of location in the y-axis back to 0 meters. And now the next thing that we have in the rigid body physics is the collision shape, and by default, the convex hull option is selected. Now this collision shape is used to calculate the object boundaries which help you to change the way the physics will work when the two objects collide. For very simple animations, we mostly use the convex hull option. However, in case of complex objects or when you are having a large number of objects in the scene that will collide with each other, then you might have to use some other collision shapes depending upon that specific object. For example, with this cube selected, if I go to the modify properties, click on add modifier, and in the generate, select the bevel modifier. Let's increase the number of segments to something like 3. Let's also increase the amount from here, and now you can see that our object is having a much complex look than before. Previously, it was a simple cube object with no bevel effect applied to it, but now we have applied the bevel modifier with the segment set to 4 and the amount set to 0.35 meters. Now let's return back to the physics properties, and if I go to the collision shape and change it to box, then in this case, we are able to see a box boundary around the cube object object, and this indicates that the rigid body physics will consider this box boundary when this cube object collides with the plane. But when the collision shape was set to the default convex hull, then in this case there was no such box boundary and it was considering the original geometry of the cube. However, if you have a large number of loop cuts or vertices or maybe subdivision applied to your object, then in that case using the convex hull collision shape will take up slightly larger amount of memory of your PC in order to create the simulation. However, by changing the shape to the box, it will no longer consider the number of vertices or any subdivision or bevel effect on your cube, because now it will only consider this boundary that is created along the cube for the purpose of collisions. So it's completely your choice if you want to select the collision shape as the box or the convex hull. But yes, one thing to notice here is that by selecting the convex hull shape, we have one more option over here which is named as the source. Now by default, the source is set to deform, and this basically means that Blender will only consider the deform modifiers that we have applied to the object in our scene. Apart from this, it will also consider any shape keys that we create for this object. Then the second option that we have in the source is base, and with this base selected as the source, Blender will no longer consider any modifiers that we have added for this object but not yet applied. Then the next option that you have in the source settings is the final, and now this one will ensure that all the modifiers which you have added to your object, whether they are applied or not, will be considered for the collision in the rigid body physics. And now moving ahead, we'll be deleting this plane from the scene, and instead of this we'll add a UV sphere and we'll convert it into a hemisphere. So press X to delete the plane, press Shift plus A, go to mesh and select the UV sphere, press 1 to go to the front view. Now tap into the edit mode, press Alt plus Z to turn on the X-ray mode. Now I'll select these top vertices, and to delete them press X and select delete vertices. Now we have a hemisphere in the scene, and suppose I want that this cube object should fall into the hollow space of this hemisphere. So for this I'll first scale up this UV sphere. So tab into the edit mode, press A to select everything and scale it up like this. Now in the physics properties, I'll be adding the rigid body physics. Then I'll change the type to passive, and now if I take the pointer in the timeline editor back to the frame number 1 and press the space bar to play the animation, then you will notice that this cube object will not consider the hollow space inside the sphere, and to solve this problem we need to change the collision shape. So for any such objects where you have some hollow space and you want it to be considered for the rigid body physics, we need to select the mesh as the shape. So with the mesh selected over here, if I take the pointer back to the frame number 1 and play the animation again, then this time the cube object will consider the hollow space inside the sphere. And now moving ahead, we have two more important options in the surface response menu, which are the friction and the bounciness. To understand these two factors in a better way, we'll again bring back the plane object in the scene. So press X to delete this UV sphere. Now press Shift plus A, go to mesh and select the plane. Tab into the edit mode, let's scale it up 10 times. Let's also apply the rigid body physics to the plane in the scene. So go to the physics properties, select the rigid body, and in the type change this to passive. Now by default, the bounciness value is set to 0 for both the plane as well as the cube object. As a result, when we play the animation, the cube will simply hit the plane and not show any bouncing animation. However, if I increase this bounciness value to something like 0.5 or 0.6, and we also need to increase the value of bounciness in this plane, so go to the bounciness value and change it to 0.5 or 0.6. And now if we replay the animation by pressing the space bar, and the reason why we don't see much change is that in the rigid body physics of the cube, we have selected the source as the final. As a result, while making the animation of the collision, Blender is considering the modifier that we have added to the cube object. However, for a better animation, we need to change this source back to the deform. Now let's replay the animation one more time, and this time we see that the cube will not only hit the plane, but it also topples due to the effect of bounciness. Similarly, if I go to the friction value and reduce it to a much lower number like 0.1 or 0.2 and replay the animation again by pressing the space bar, then you will notice that this time also the cube will bounce and topple. However, the distance by which it moves due to the toppling has now reduced, and this is because of the friction value. Similarly, if I change the friction value to a very high number like 0.9, and let's also take the pointer back to the frame number 1, let's also change the friction value of this plane object from 0.5 to 0.9, and now press the space bar to play the animation. Now this time you will notice that the amount of displacement of the cube is much higher due to the higher value of friction. And now moving ahead, in order to revise what all we have done in this chapter, we'll be creating a simulation with the rigid body physics where we'll have a glass bowl and some candies will be falling in it. So first of all, I will be deleting the cube and the plane, so press X to delete both of them. Now for the candies, we'll be creating some very simple shapes in the scene. So first of all, let's add a cylinder. So press Shift plus A, go to mesh and select the cylinder. Let's tab into the edit mode, scale it down in the Z axis and left click to finalize. Now press 3 for the face select mode, select the top face, press I to inset. Let's also extrude it down in the Z axis. Now to give it a better look, first of all right click and select shade auto smooth. Let's also apply the bevel modifier to it. So go to the modifier modify properties, then click on add modifier, and in the generate, select the bevel modifier. I will be increasing the number of segments to something like 3 or 4. Then if you want, you can also try to change the amount from here, but for now, I'll be keeping it to the default value of 0.1 meters. And finally, we have a simple candy ready for our scene. Just like this, let's also create another candy in the shape of a cube. So press Shift plus A, go to mesh and select the cube. Let's move it in the Y axis and place it over here. Now go to the modify properties, click on add modifier, and in the generate, select the bevel modifier. Let's increase the number of segments to 3 or 4. Let's also increase the amount from here, and we'll be keeping it to a value of somewhere near 0.4 or 0.5, and now it looks perfect. Also right click and select shade auto smooth. Now let's also go to the render view, and to improve the lighting, I'll select the point light. Let's go to the object data properties, and let's increase the power from 1000 watt to somewhere near 2500 watts. Now press 7 on the numpad to go to the top view. Let's move this lamp over here, press Shift plus D to create a duplicate and move it in the Y axis. Similarly, I'll select both of these lights, press Shift plus D to create a duplicate and place them on the opposite side also. Now we have enough lighting in the scene, and now to create the glass bowl, we first need to add a UV sphere in the scene. So press Shift plus A, go to mesh and select the UV sphere. Now tab into the edit mode, press S to scale it up. Now with the vertex select mode, let's go to the front view by pressing 1 on the numpad. Let's also go to the solid view, press Alt plus Z to turn on the X-ray mode, and now we'll be deleting the top vertices of the UV sphere. So let's select all these vertices on the top, press X to delete and select delete vertices. Now we have a shape like this. Let's also turn off the X-ray mode, and to give it a better look, I'll be selecting this edge loop at the top. So hold down the Alt button and left click over here. Now press E to extrude it in the Z axis. Then left click to finalize, and so this is how it looks. Let's now return back to the object mode, right click and select shade auto smooth. To give it a much better look, let's go to the modify properties, click on add modifier, and in the generate, select the bevel modifier. Let's increase the number of segments to 4, and finally this is how the glass bowl is looking. Now for the material of the glass bowl, let's first go to the render view. Let's also change this window to the shader editor. So click on this icon, and from here select the shader editor. Now to create a new material, click on the new button. Let's zoom in, and we have the default principle BSDF applied to our object, but to make it look like glass, we'll be adding a mix of glass BSDF and the transparent BSDF. So first of all, select the principal BSDF, press X to delete it. Now press Shift plus A, go to shader and select the glass BSDF. Let's place it over here. Now if I connect the glass BSDF to the surface socket in the material output, you will notice that we are not able to see the glass properly, and to solve this problem, we need to use some HDRI in the scene. So for this, click on this drop down, and from here turn off the scene world. Similarly, if you want to view the HDRI around the scene also, then for this, change the world opacity value from 0 to 1. Let's also reduce the blur, and now we can clearly see that this bowl is now having a glass material applied to it. However, to make it transparent, we also need to use the transparent BSDF. So press Shift plus A, go to shader and select the transparent BSDF. Let's place it over here. Now to connect both of them to the material output, we need to use the mix shader node. So press Shift plus A, go to shader and select the mix shader. We'll place it over here. Now I'll take the BSDF socket in the transparent BSDF and connect it to the mix shader. To make it look even better, go to the render properties and turn on the retracing. Also in the material properties, scroll down, and in the surface settings, turn on the ray trace transmission. And now you can see here that we have a realistic looking glass material applied to the glass bowl. Also for the base, let's add a plane object at the bottom. So press Shift plus A, go to mesh and select the plane. Tab into the edit mode, press S to scale it up 10 times, or maybe let's double it up. Now let's move it down in the Z axis. So press G, Z and place it over here. To change its color, go to the shader editor, click on the new button, and in the base color, I'll be changing this to the blue color. Now we also need to animate the candies by using the rigid body physics. So for this, let's first go to the solid mode, select this candy at the top. Let's tab into the edit mode, press S to scale it down, and let's do the same with this cube also. To place it near the first candy, press Alt plus G to reset the location. Tab into the edit mode, scale it down. Let's also move it up in the Z axis. Now it looks like a sphere because we applied the bevel modifier to it, and when we scaled it down, the bevel vertices are making it look like a UV sphere. So let's go to the modifier properties, and in the bevel modifier, I'll reduce the amount from here. So I'll keep it to something like 0.1 or 0.15, and now it looks perfect. Now we'll be having more than one candies in the scene. As a result, let's select both of these candies, press Shift plus D to create a duplicate, and move them up in the Z axis. Now instead of repeating the same step again and again, we can use a shortcut, which is to press Shift plus R. This will repeat the last step that we did in the Blender file. You can keep as many candies as you like, but for now, I'll be keeping it to somewhere around 10 or 12 candies. So I'll press Shift plus R one more time, and now it looks perfect. All these candies will fall into the glass bowl with the help of rigid body physics. Now moving ahead, let's also give some material to these candies in the scene. So I have switched to the render view. Let's select this first candy, go to the shader editor, click on the new button, and now we'll be using the same material which is saved with the name material.002 for each of these candies. But to give each of them different colors, we'll be using the color ramp node along with the object info node. So press press Shift plus A, go to converter and select the color ramp. Let's place it over here, connect the color socket to the base color. Let's also change the interpolation mode from linear to constant. Now with the first pointer selected, let's change the color by first increasing the brightness from here, and for the first one, I'll be choosing the red color. Let's select the second pointer and I'll change this color to the blue color. To create some more colors, click on this plus button, then change the color from here and I'll be choosing the yellow color. Let's do the same thing 2 more times. So click on the plus button again, change the color from here, choose the green color, and one last time click on the plus button. Now we'll change the color to the pink color. Now to place all these pointers evenly distributed from each other, click on this icon and select distribute stops from left. Now you can see here that since we have applied the material to only the first candy, as a result we are not able to see this material with different colors on the other candies. And to solve this problem, we need to select all the candies in the scene. So let's select all these candies except the one which has the material.002 applied. Now with the shift key holded, select this candy which has the material applied. Now press Ctrl plus L and from here select the link materials. Right now all of them are of the same color, and to give them some random colors, go to the shader editor, press Shift plus A, go to input and select the object info node. Let's place it over here, take the random socket and connect it to the factor. Now each of them are having some different colors. Also, to give them a plastic-like or a reflecting look, I'll go to the principal BSDF and reduce the roughness value to somewhere around 0. And now we are ready to create the animation. So first of all, I'll select this candy which will first reach the glass bowl, and with this selected, I'll go to the physics properties and turn on the rigid body physics. Now to give the candy some bounciness, go to the surface response settings, and in the bounciness value, I'll be entering 0.2. Now we have the rigid body physics applied to only this candy and not the rest of the candies. And instead of applying the rigid body physics separately to each one of these, we can do a very simple thing. So first of all, select all these candies except the one on which we have the rigid body physics applied, and now with the shift key holded, select that particular candy at the end. Now go to the object settings and in this list, go to rigid body and select copy from active. By doing this, we now have the same rigid body physics applied to each of these candies. Now let's also apply the rigid body physics to this glass bowl. So I'll select it, go to the physics properties and select the rigid body physics. Since we don't want the gravity effect to be applied on this glass bowl, so I'll change the type to passive, and since we want the candies to go inside the hollow space of this glass bowl, so we also need to change the collision shape to the mesh. Also, let's increase the bounciness value to something like 0.2, and now we are ready to view our animation. To ensure that the animation runs smoothly, let's first go to the object mode. Also, I'll change this window to the timeline editor and take the pointer back to the frame number 1. Now let's adjust the view properly and press the space bar to play the animation. And now you will see that all of these candies move in a straight line and fall into the glass bowl. Now to give the animation a much more natural look, we need to do some changes in the location and the rotation of these candies in the starting frame. For example, I'll select this candy at the bottom and we'll move it down in the z-axis. So what we are basically doing is that we'll randomize the distance between each candies and also give them some random rotation. Similarly, I'll select this one also. Let's move it over here. Let's also give it some random rotation, and we'll be doing the same thing with each of these candies. Let's select this one also, rotate it, place it over here. So all these changes are completely random, and it totally depends upon you that exactly what changes you need in the location, rotation and the scaling of different candies. Let's do the same with these candies also. Let's move this one up in the z-axis. Let's select this one, move it over here. Let's scale it up slightly. Let's select this, move it down in the z-axis, and similarly this one also. Let's rotate it like this and move it down in the z-axis. One more thing, all the 3 candies at the top are having the same color, and to solve this problem, let's go to the shader editor and slightly try to change the position of the different pointers. In this way, we can assign different colors to each of these candies. Now let's return back to the timeline editor, and now it's the time to view the final result. So press the space bar to play the animation, and so finally this is how our animation looks. Also, we have this one candy that is falling outside the glass bowl, and it's even passing through the plane object in the scene. And to avoid this, I'll select the plane in the scene, go to the physics settings, turn on the rigid body physics and change the type to passive. Now let's replay the animation one more time by pressing the space bar, and so this is how this candy animation looks. And in fact, this time that one particular candy managed to get inside the glass bowl, and this is because there is no one such particular animation that it will always follow for a specific number of objects placed at a specific location, rotation or scale. And the main reason behind all this is that, as I told you in the beginning, the Blender simulations try to give you the same results that you would expect to get in the real life. And with this, we now arrive to the end of this chapter. Today we understood about the concept of rigid body physics, and in the end we also created this simple animation with some candies and a glass bowl. And as a homework of this chapter, you can try to create the same scene but with a much higher number of candies. In this way, you will learn about how a much larger number of objects will interact with each other with the rigid body physics. And so our next chapter will be the chapter number 65, Cloth Physics in Blender. So don't forget to subscribe to our channel, press that notification bell so that you can get timely updates updates about the upcoming chapters. Thank you for watching and we'll see you in the next one.